circuit given like this. Here we have 8 ampere passing through this circuit. Let's say we want to find the current passing through this 5 ohm resistor. Let's say it is I1. Let's call this one I2. You can assume any direction. If you get it wrong, you're going to get the negative answer. So it's always going to be right. So you can just assume the directions of the current. Here I'm assuming the current is going this direction. Let's call this one I3. Let's call this one I4. Let's take this direction for it, I4, and that's it. Let's name this resistor as well. Let's call this resistor R1. Let's call this resistor R2. Let's say this is R3. Let's call this one R4. Let's call this one R5. Okay. Now here we want to find out the current I1, I2, I3, I4, and also the voltage across the nodes. Let's call this voltage V1. Let's call this voltage V2. And let's call this voltage V3. And with this voltage we already know this provided, that's 50 voltage. So let's try to find it. The first thing I can do is I can apply KCL at this node V2. So let's do that. KCL at node 2. What KCL says? KCL says summation of current is all the current is equal to 0, or summation of current in is equal to summation of current out. Let's do the summation of current in is equal to summation of current out. If I do that, what are the current entering this V2 node? We have 8 ampere current that's entering this V2. So we are going to have 8 right here, and I1 is exiting the node, also I2 is exiting the node. So 8 is equal to I1 plus I2. Okay, let's apply KCL at V3 as well, the node V3. KCL, so this is equation number 1. KCL at node 3. Let's call it node V2 so you can see it clearly. Node V2, node V3. So if I apply KCL at node V3, summation of current in is equal to summation of current out. What is the current is what are the currents entering this node? I2 is entering, I4 is entering, I3 is exiting. So I2 plus I4 is equal to I3. Yes. So here you can see for the first equation we have 2 unknown variables. For the second equation we have 3 unknown variables. So we cannot do that because like there are a lot of unknown variables. Even if I combine, we still gonna have 3 unknown variables. So we cannot simplify this case here just by keeping it as current. So what I can do is I can convert all of these current into voltage and try to solve for it. Now let's convert them into voltages. So first let's look at the current passing through this. Here we have current provided, that is 8. Let's call this one Ix. Okay, Ix is equal to 8 ampere. So if I create an equation for it, since current is flowing from here to here, V1 is the higher potential because current flow from higher potential to the lower potential. So we are going to have V1 minus V2 divided by 10, that is equivalent to 8 ampere. Okay, this is one of the relation we can make, and therefore this is going to be V1 minus V2 is equal to 80. Okay, let's keep this one alone, and then let's go and create the equation for the other current. And also the bottom one, always the reference voltage, this is connected to the ground, so this is going to be always 0. And here if I look at I1, the equation of I1 is going to be V2 minus 0 divided by the resistor in between. So that's going to be basically V2 divided by 5. And if I look at the I2 going from here to here, so V2 minus V3 divided by the resistor in between. So V2 minus V3 divided by 5. And then if you look at I3 is going from V3 to ground. So V3 minus 0 divided by the resistance in between. So this is going to be V3 divided by 4. and I4. I4 is going from 50 to V3. So 50 minus V3 divided by the resistance in between. 50 minus V3 divided by the resistance in between, that is 10. Okay. So if I apply these things in this equation, how many unknown variables? We have 1, 2, seems like we only have 2 unknown variables, so it's going to be easier to solve. Let's try it. So if I plug the current values in this equation, let's see what happens. 8 is equal to I1 is what? V2 divided by 5. V2 divided by 5, and then I2, that is V2 minus V3. V3 divided by 5. So here I have 2 unknown variables. So I still need another equation. So let's try this equation we derive from node V3. So here I2, instead of I2 I put V2 minus V3 divided by 5, and then instead of I4 I plug 50 minus V3 divided by 10, and instead of I3 I plug V3 divided by 4. So this one seems like, this one you can see like I can solve for the V3 directly from here. Okay, so I need to erase something, or I have to move this to the another page. Let's create another page. New page, create, let's go. Okay, so I'm bringing this equation. I'm going to copy paste it right here. Control C, Control V. Okay, let me do that and solve for V3 here. So here we have, we have 2 unknown variables. So we have to simplify this one and connect these two together. Here we have V2, V3, V2, V3. So to simplify this one, what I can multiply? You can think about a value. If you multiply, all the denominator will cancel. So here I am seeing 20, because 20 also divide by 4, 20 divides by 10, 20 divides by 5. So if I multiply the whole equation by 20, this is going to become V2 minus V3 times 4, and then this one become 2 times 50 minus V3, and that's equivalent to 5V3. And if I multiply and simplify, this is going to be 4V2 minus 4V3 plus 2 times 50, that's 100, and 2 times negative V3, that's negative 2V3. That's equal to 5V3. Now let's add the like terms. So let's bring the V3s and V2s to the other side of the equation. I keep the 100 this side, so this is going to be 100 is equal to 5V3 plus 2V3 plus 4V3 minus 4V2. 5 plus 2, 7, 7 plus 4, 11. So 11V3 minus 4V2 is equal to 100. This is our equation number 2. Okay, now we have equation number 1 here, equation number 2 here. Equation 1, I can still simplify this one furthermore. So let's do that here. I'm copying this one. And bring it here. Okay, let me use a different color so it doesn't mix up. Okay, here we have 8, and think of a value. If I multiply, all the denominator will cancel. I can think of 10, because 10 divided by 5 is 2. Or you can just multiply by 5. 5 is easier, so this is going to cancel it. If I multiply the whole thing by 5, this is going to become 40. That is equivalent to V2 divided by 5. Actually 5 cancels, so V2, and then here we are going to have this V2, this is V2 minus V3. The V3 is hidden, so V2 minus V3. Now we have got rid of all the denominators, and this is still plus right here. So this is going to be 2V2 minus V3 is equal to 40. So now we have simplified both of these equations. Now we can put them together and try to cancel something. So 2v2. So if you think about, like, here we have negative 4v2. If I multiply this equation by 2, this one also become positive 4v2. So if I do that, this is going to be positive 4v2 minus 2v2, that's equivalent to 40 times 2, that's 80. And then here we have, if I bring this one here, this minus 4v2 plus, wait a minute, multiple, this is v3, okay, this one is v3, and this is 11v3, that's equivalent to 100. And if I add them together, v2 cancels, and then 11v3 plus minus 2v3, that is 9v3. 9v3 is equal to 180, and therefore v3 is going to be equal to 9 times 2, so 20. v3 is 20 voltage. Okay, now we have solved for the v3. If we have v3, we can find out the v2 easily by putting it in one of these equations. So here, this one is the simplest equation, so I'm going to plug this one right here. Let me use a different color for it. So let's rearrange this equation in terms of v2. So this is going to be 2v2 is equal to 40 plus v3. 40 plus 20, that's 60. Therefore v2 is going to be 60 divided by 2, that's 30 voltage. So now we found out v2 and v3. Since we have v2 and v3, we can find almost all the current, I think. Let me see. I1 v2 v3 involved, I2 v2 v3 involved, I3 v2 v3 involved. So we can find all the current right now. Let me erase all these things. So let's look at the current I1. I1 is v2 divided by 5. We found out v2 is equal to what? 30. So 30 divided by 5, that's equal to 6 ampere. I2 is v2 minus v3 divided by 5. What is v2? v2 is 30, and then v3 is 20. So 30 minus 20 divided by 5. 30 minus 20 is 10 divided by 5, that's 2 ampere. 2 ampere. And then I3, v3 divided by 4. What is v3? v3, we found out that's 20 voltage. 20 divided by 4, that is 5 ampere. And then I4 is 50 minus v3 divided by 10. What is v3? v3 is 20. So 50 minus 20, that is 30. 30 divided by 10, that's 3 ampere. Now we have solved for all the currents. And what else left? Let me see. So we found out all the currents. Now we found out v2, v3 voltage. The only voltage we didn't find is v1. So we can use this equation to find the v1 right here. This is the one we derived earlier. It is still there. Let me erase these things and solve it here. Okay. So this one is v1 minus v2 is equal to 80. We are trying to solve for v1. So v1 is equal to 80 plus v2. And we found out v2, that is 30. So this is going to be 80 plus 30. That is 110 voltage. So let's actually see if it makes sense, if I'm making any mistake. So here 8 amperes entering, so the current entering should be equal to exiting. Here I1 is 6 ampere and I2, what I got, 2 ampere. So this one makes sense because 8 ampere entering, 8 ampere exiting. So this is right. Let's look at this circuit. Here we have got I4, that is 3 ampere, and then I2, what value? I2 is 2 ampere. So 3 and 2 are entering, 5 is exiting. So this one makes sense. All the entering currents equal to exiting. So we did it perfectly. That's it for this video, guys. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.